Hello everyone, we are going to do a little bit of review on linear patterns and some basics around slope and how to write the equation of a line that you had learned previously, but is important for our work here and would be good to review so that we can hit the ground running. So first off, let's think of linear patterns and what is a linear pattern. So to be pretty straightforward, a linear pattern really is about the points forming a straight line. So let's say that. So the points form a straight line. All right. And then, within that, we can also talk maybe about the slope or rate of change, because that's kind of crucial. So the slope, which is sometimes referred to as the rate of change, where slope is the steepness of the line, we'll talk about that again, is the same from one point to the next. The slope or the rate of change is the same from one point to the next. So how does that look in a couple different ways? So we can represent a linear pattern with a few different representations. So a table, a graph, and an equation might all be used to represent a linear pattern. So let's start off with a table here. So let's make a table and let's put X and Y on the two sides of the table. I'm just going to make up some values here. So let's say our X values are something like -2, -5. -1, -3, 0, -1, 1, 1, 2, 3. So if this is a linear pattern, that means that our rate of change is the same from one point to the next. And so I'll notice as we are going down our X values, or our X values are actually increasing. And each one of these step sizes is the same. That's important. So those are all going up by 1. And then we'd be looking for the step size over on the Y values to also be increasing by the same amount. If the X values are increasing by the same amount, then so should the Y's if it's linear. So notice that's increasing by 2. From -5 to -3, you're actually going closer to 0. So it is increasing by 2. Increasing by 2 again. From -1 to 1 is an increase of 2, and from 1 to 3 is an increase of 2 as well. So if we write over here our slope, again, also referred to as the rate of change, is increasing by 2 for every one X value. So the Y's are increasing, so we're going up by 2 for every one X. So it's a change in Y over change in X. We're going to talk about that a little bit on the next page as well. And so in this case, 2 divided by 1, the slope really is just 2, or the rate of change is 2 here. So we can see that on the table that the Y values are increasing by the same amount each time as the X values are increasing by the same amount each time. All right, let's take a look to see how that shows up in a graph. So let's make a Y-axis here. Let's see if I can get it to make a straight one for me here. There we go. Just do your best little sketch here. And let's try to make a scale. So let's make like 5 equal marks. 1, 2, 3, 4, 5 on each one of these. 1, 2, 3, 4, 5. Just do the best you can with this. 2, 3, 4, 5. Try to make them as equal spaced as you can. 3, 4. And that's as much as I can ask right now. So remember, we have a Y-axis, that's the vertical, that's the up and down, and then we have the X-axis, which is the horizontal or side to side. So let's just plot out the points that we had on the table. So we had -2, -5. So that'd be -2 on our X, -5 down here on our Y. So left and down 5. So we would have that. All right, -1, -3, So left 1 and then negative 3 would be right there. 0, negative 1 would be over 0 and down 1. And 1, 1 be right here, and then 2, 3. Now if I made these well, then those should all line up, and they're pretty close. I might have to fudge a little bit since I'm sketching. It's not the end of the world. So let's draw in our line here. Yeah, so we want that to be straight, because notice it's pretty good. I'm just going to kind of fudge these a little bit so it looks like they're all nicely lined up. Excellent. All right. So the points need to form a straight line if this is a linear pattern. And so you notice there's a few pieces of information that we can notice here. One that we're talking about is the slope. So remember the slope, sometimes we make a little slope triangle here to show that the rate of change is the same. So notice that that's going up by 2. Every time we go over 1, it goes up 2 on the y. So the change in y is 2, the change in x is 1. So every one of these, if I did that here, for instance, that would also be 2 over 1. So the slope, which is sometimes referred to as rise over run, is 2 over 1, and 2 divided by 1, again, is just 2. So that's our slope. And the other piece of information that we're probably going to need eventually is the Y-intercept, where the line crosses the y-axis. So Y-intercept right here is at -1. Technically, the coordinates would be 0 and -1. So those are a couple pieces of information. But in terms of the graph itself, it's a straight line. I mean, that's what we want. Now, the equation of the line, we're actually going to have a couple forms of linear equations that we're going to talk about, but the one that you know best is the slope-intercept form, y equals mx plus b. And in this case, let's just go ahead and write it as we see here in our situation. And there's also a point slope form that we're going to talk about. So y equals, our slope is 2, so y equals mx plus b means that we're going to put our slope in that spot. I'm just going to color code a little bit so I can highlight the slope and the y-intercept. And then plus our y-intercept, which in this case turned out to be -1. So y equals 2x plus -1. Or if you just want to simplify that a little bit, maybe a little cleaner way to write that is, I'm just going to continue to color code, y equals 2x minus 1. Instead of writing plus -1, we can just clean that up a little bit and write -1, where again, this is our slope, and then this, including the negative sign, is our y-intercept. Now that's the slope-intercept form of a linear equation, and we can write a couple different types of forms, standard form and also the point slope form, which we'll talk about on the next page.